So I said I would record myself. Here's my attempt at recording myself. It's not going to be edited whatsoever. So here goes. If I look at problem set 1, the synthesis question from problem set 1, it says synthesize 2-butanol, that's this guy, from acetylene, that's this guy, 2 carbons, C triple bond C with 2 H's on each end, 1 H on each end. So what? This acetylene has 2 carbons and my 2-butanol has 4 carbons. That means I'm going to need to make a carbon-carbon bond. So if I need to make a carbon-carbon bond, I need to use an acetylide, that's this guy, carbon triple bond with a minus, an acetylide ion to make that carbon-carbon bond. So here's how I'm going to start. I'm going to turn my acetylene into an acetylide, meaning I need to pluck a hydrogen off of that terminal end. I need a strong base in order to do that. And a strong base, you can choose lots of them. Sodium hydride is one of my favorites. NaNH2 is another very common one for deprotonating an acetylide ion. Sodium hydroxide is not strong enough to deprotonate an acetylide, deprotonate an acetylene to make an acetylide. So it's got to be a pretty strong base. Sodium hydride, sodium amide, that's what this is. Strong base, deprotonate that acetylene to make acetylide. I need to add 2 additional carbons to my structure. And so the way that we learned to do that with acetylides was through SN2 reactions. Acetylide, SN2 on my primary alkyl halide, and I get a new carbon-carbon bond. So you may not remember, that was supposed to be color-coded, but it's the wrong color, so we're just going to screw it now. You may not remember why we have to do it this way using an acetylide, but an alkene with a minus, those are not terribly stable things. Those are crazy, scary, strong bases. They don't really work like this. An alkyne with a minus, though, is a very stable thing for doing SN2 reactions to make carbon-carbon bonds. So I've put my carbon-carbon bonds together, made this guy, and then I can reduce my alkene, I can reduce my alkyne to an alkene like this. Alkyne to alkene, I've got 2 options. That's H2 and Lindlar's catalyst, or Na and NH3, the dissolving metal reduction. NaNH3, I almost wrote the wrong thing. This one does cis, while that one does trans, but it does not matter whatsoever as the product of this reaction, whether you do cis or trans. And then finally, I need to do a Markovnikov addition to get an OH on my secondary position. It can be Markovnikov with rearrangements or without rearrangements. It's not going to rearrange here, so you can do acid and water. Or you can do mercury, and it does not matter which one you choose. Mercury and water, followed by NaBH4. So that's almost perfect. But there's this weird little thing, this weird little phrasing that was in the problem that said, using acetylene as your only source of carbon. That's where this can get a little bit tricky. Don't freak out on me. Stick with me for a second. This thing is not acetylene, and that brown circled thing ended up as part of my reaction. So what that actually means, according to synthesis rules, it means that you need to show how to make that piece from acetylene as well. So I can draw out that whole bottom synthesis and make everything reasonable, but I officially need to make everything from acetylene as your only source of carbon. So in order to make, we'll call this piece A, I use this synthesis up here where I turn my alkyne into an alkene, and then I turn my alkene into an alkyl halide. But I haven't given any reagents yet. Let's do that. This can be H2 and Lindlar's catalyst, or it can be Na and NH3. It doesn't matter, cis or trans. And this is simple HBr, the very first reaction you learned. Alkene plus HBr, Markovnikov addition, no rearrangements. We don't care. It's making the best carbocation it can. Done. So since I'm recording myself saying this, I'm going to go ahead on this little rant to say, don't look at these synthesis problems and totally freak out. The number one thing I saw was I had 2 carbons that I'm allowed to use and 4 carbons that I needed to have in my final product. So I need to make a carbon-carbon bond. You have learned very few carbon-carbon bond forming reactions, and this is one of them. This is very relevant to our current material because it's still SN1, SN2, E1, E2 kind of stuff that we're learning. But alkyl halides work best for these substitutions, not alcohols. We're currently learning alcohols, but alcohols aren't good at this kind of substitution. So you might look at this and say, does she expect us to be able to do that? Well, yes, but we're also practicing now so that we can get less rusty on it. I may not ask you this specific type thing on Monday, but this will become part of what we do routinely. As you may notice, H2 and Lindlar's I used here and here. HBr I used here to get this. There's an, whoops, sorry. HBr I used, H2 and Lindlar's I used here and here. So I repeated the same reagent because I need to do the same things in different ways. So you will get used to like a couple of reactions that we will use again and again and again. That's my point here. So it's not that you have to remember every single reagent from last semester in order to do well on synthesis. You will develop some reagents that are your favorites, and you'll get used to using those routinely. Okay, that's the synthesis from Wednesday. What about the one from today? The one from today, synthesize that thing from 2-butanol. 2-butanol. We need to make, this is butyraldehyde. That's the common name of it. Right now, I can't think of the IUPAC name, but so I need my secondary alcohol to be turned into a primary alcohol. These are just thoughts coming out right now. Then I need my secondary alcohol to be turned into a primary alcohol so that I can then oxidize it to an aldehyde using a weak oxidizing agent. Can you turn a secondary alcohol into a primary alcohol directly like that? No, you cannot. So how might we go about this? We could turn our secondary alcohol into maybe like a BR, and then turn that into maybe like an alkene on the end, and then turn that into maybe like an alcohol on the end. This is one way to do this. This is not necessarily the only way. There are other ways that are perfectly legit. We could use HBr to do that. That would do an SN1 mechanism. You don't have to tell me that part, but while I'm here, I'm telling you that part. You could do HBr to do this through SN1. It would go through a carbocation. It could shift if shifting is possible, but it's not possible here. You could do PBr and pyridine. PYR. PBr and pyridine does not rearrange because it's with base. So that can sort of hedge your bets that it will always do an SN2 reaction. But it's turning alcohol into alkyl halide. Why would I turn it into an alkyl halide? Well, because Kotbu is my very favorite reagent for eliminating an alkyl halide. If I can eliminate this alkyl halide in a very particular way, meaning anti-Zaitsev, then I can get this terminal alkene over here. Secondary alcohols are sort of difficult to go directly from, let me find a different color, to go directly down this green path from this secondary alcohol to this terminal alkene. Those are pretty difficult to do. To make an alcohol do anti-Zaitsev, that's pretty difficult. You have to do some fancy schmancy stuff to get this secondary alcohol to dehydrate to a terminal. So I'm much more comfortable with alkyl halides and controlling their Zaitsev, anti-Zaitsev. So that's why I went down this alkyl halide path. Okay, back to where we were. So anti-Zaitsev, give me an alkene on the end. I need anti-Markovnikov, so that's BH3, followed by hydroxide and peroxide. That gives me anti-Markovnikov, CN addition, but it doesn't really matter here because we can't tell stereochemistry. And finally, I need a weak oxidizing agent. That means choose your favorite weak oxidizing agent. PCC is one of my favorites. I think it's one of students' favorites probably. It could also be the Swern oxidation reagents. It could also be the bleach oxidation reagents, a weak oxidizing agent. That's what synthesis I would do for this one. I'm done. Goodbye.